Good morning, guys. Anjani Kumar here, dealing Power System 2 for third year electrical students. In the last session, we completed what are the factors that are affecting for a SAG itself. Alright. In the last session, we discussed about what is the definition of a SAG, what is the definition of a span, right? What is a tension, right? What are the influence when curvature present in the transmission line as a curved shape, right? And after that, what are the factors that are going to be affects the sag? These are the things we discussed in the last session, right? Now it's very important. So what is the shape of a transmission line curve? When it will be called as a catenary curve? When it will be called as a parabolic curve? So when we can call it as a catenary curve means if the length or a span should be greater than 1000 feet. So then we can call it as a catenary curve. That means the span greater than 1000 feet. So then this type of curve we can call it as a catenary curve. If it is less than 1000 feet, so we can call it as a parabolic curve. Because all the transmission line, HV transmission line that we are using are less than 1000 feet. Right? Almost all 110 meters to 132 meters only. So that means these less than 1000 meters. That means all the transmission line, HV transmission line that we are using, that we are seeing from your real life. So those are a parabolic shape. But the shape catenary shape means if the catenary shape is present in the system, we can get the accurate result of a sag. How much sag that is going to be present in the system. Alright, all these things will get accurately when the shape is a catenary curve. Alright. After that, what are the influences? You know about influences. What are the influences? Right, the first is at any point in the curve, at any point, right? For suppose these two are a transmission towers, right? For suppose this is a transmission line curve, right? This is A, B. At any point from A to B, the tension is a constant value. Right? Throughout the line, the tension is a constant value. Right? After that, tension always present at any point tangentially. This point tangentially, this point tangentially. Right? The tension will be present tangent in nature. Alright, each and every point that it has some vertical projection and horizontal projection. For suppose if you see, the tension will create vertical and horizontal. Vertical and horizontal. At midpoint, we don't have any vertical, only horizontal tension will be present. We already discussed in a last session also. Right? If the load is present, all the loads is uniformly distributed in a transmission line. If the load is distributed or concentrated at midpoint, at this point, so then we can call it as a catenary shape. The shape is a catenary shape. That means load is uniformly distributed and concentrated on midpoint of a transmission line. So then we can call it as a catenary shape. Alright. If the load is uniformly distributed throughout the line, so then the shape of a line will be a parabolic shape. Right? The shape will be parabolic shape. Right? So these are the things that we are influenced, that we are getting from this SAG calculations, right? And after that, what are the factors? We discussed about what are the factors. Factors that affects sag value. We discussed about. So first factor is a weight of the conductor. Right? First factor is a weight of the conductor. Definitely, if the weight of the conductor increases, your sag is going to be increases. For suppose, if the conductor is like this, if the weight is increases, the conductor starts, downwards. That means the sag is going to be increases. Right? It depends on weight of the conductor. So sag is directly proportional to the weight of the conductor. And after that, the second one is a location of a conductor. Right? Due to the climatic conditions, the countries like Canada, Norway, these are very cool countries, right? Ice falling countries. So when a transmission line placed in that areas, the ice will be surrounded. The transmission line is surrounded by the ice itself, right? If the transmission line like this, the ice will be surrounded around the transmission line. So what happened? The weight of the conductor also increases. Then the sag will be increases, right? The sag is depends on the location of a conductor also. Right? That means the location of a conductor. If it is a cool area, ice will be surrounded, right? So due to that, weight will be increases. If the weight increases, automatically my sag will be increases. Next, the third one is the length of the conductor. If the length of the conductor is increases, what about the sag? Sag is going to be increases. If the length is increases, the sag is going to be downwards, right? If the length is like this, the sag will be here. If the length towards increases, the sag will be increases. So this is the formulas, right? And after that, the tension. Right? You will know whether the tension is going to be increases, the sag is going to be reduces. So sag is inversely proportional to tension itself. Right? So what are the factors that are affecting the sag means? The first one is the weight of the conductor. Right? And second one is the location of a conductor, where the transmission line is going to be erected. So what are the states? Right? There are probably ice coated, right? We'll discuss what it means. If the ice loading is present, how the sag will be varies, we'll discuss, right? After that, the length of the conductor, right? If the length of the conductor increases, your sag also increases. You know about the tension. If the tension is going to be increases, right? So the tension is going to be increases, automatically the sag is going to be reduces. Tightly lage anko, sag emotadi reduce avta untadi. But we don't have that much tension. So sag must be, we are ensured that the perfect sag should be maintained in order to erect a perfect design of a transmission system. Right? So these are the things that we discussed in a last session. So don't worry, my class for up to 5 to 10 minutes, I'll explain what are the concepts that we discussed in our last session. So before starting to this session, right? So if you have any doubts regarding my sessions, you please call to my number. Definitely I will be ready to solve whatever the doubts that you have. Right? Now we just go for sag calculations. Very, very important concept, the sag calculations. Definitely we'll get a question from here. Right? So we can calculate the sag. So depends on the height of the towers, right? So we can calculate the sag on two ways. The first one is equal height of the towers. If the two towers are equally heighted and the transmission line is going to be placed between the towers, right? Equal height. Towers. And the second one is unequal height of the towers. So So the sag we can be calculated in two ways. The first one is the equal height of the towers, what is the sag value, unequal height of the towers, what is the sag value. So these are the two things we need to remind in order to maintain the sag calculations. So unequal height means in a hilly areas, right? One transmission tower is going to be in downwards, other transmission tower will be on the top of the hill. That means there is a height difference between the two transmission line. In that situation, how much the sag is going to be inserted in the system. So how much sag we should maintain in the system, we just calculated, right? The first one is the equal height of the towers. So we need to calculate the equal height of the towers. First I'll explain the figure. After that, alright. So we have two towers, right? The two towers are equally height. Right? Equally height. So I'm not that much good at drawing. So this is a transmission line. This is a transmission line. So these points A, B. So the total length we can call it as L. So that means the length of the transmission line is L. So this is a midpoint, so we can call it as a O. So this we can call it as a sag. So from the highest point to the midpoint, we can call it as a sag. Any doubts? So from this, what is the length of the transmission line is L. So what is that value? L by 2. So what is this value? L by 2. Right? So now the curve is very little bit, so very small curve. So that means we have to assume one point. So with that we can easily solve the system, right? Solve the performance, right? I'm assuming a point P here. So I'm assuming a point P here. Now what is the length from O to P? So each and every point P means if it is a curve like this, if the system, if you are placing a point P, so this we can call it as a x coordinate. So this we can call it as a y coordinate. In that system, the point P which is having the x coordinate and y coordinate. So this is we can call it as. So this we can call it as x coordinate. This we can call it as y coordinate. Got it now? See whatever it may be, right? So this we can call it as an x coordinate, each and every point P which is having x coordinate and y coordinate. And now what is the tension acting on the O? So this point which is having a tension, which is the force, which is nothing but a tension which is tangentially. So that means if you assume a point P, so that it has two coordinates. What are the coordinates? X and y, right? Now the tension, that is nothing but force which is acting at O. So that is a tangential force. So what is the tension? T. It is nothing but force. So this force is acting as a tangential force. Because the curve is very that much, not that much length, right? So for this we have a small thing. So what is the thing? OP and a curve we are choosing. So with that we are going to solve the sag issues, right? So I don't want to take all the, because each and every point the tension is equal, right? So for this I have to take little bit point, right? So for this point at point O, the tension will placed each and every point tangential direction. So the tension will be like this, right? So from OP, between O and P, there is a force acting, one more force. So that force will be downwards. At midpoint you will get the force. So at midpoint, you'll get the force here. So what is that force? W into x. Force is nothing but weight into distance, right? So that is nothing but Wx. So there are how many forces? There are two forces acting on the system. So what are the force? One is a tension force, and another one force is W and Wx, which will be exist portion of a point O and P. Right? How many forces? There are two forces. One force due to the tension, another force due to the Wx. So these two forces are equal at any point, right? Now we'll clearly explain. So from here, so L is a length of span. So W means weight of the conductor. The conductor per unit length. Alright, and after that T will be the tension in the conductor. Right, you assume a point P which is having a two coordinates, x coordinate and y coordinates. At point O we have a force. That force is nothing but tension which present in the tangential direction. Alright, after that if you take the point, you already taken a point P. In that curve also you have a force value. That force value will be Wx. Alright, so that force value will be Wx. You know about that. So the torque will be, at any point the torque will be equal. Right, movement is there, na? Sag is nothing but movement, some movement. So the torque will be present in the system, right? So what is a torque? So torque is nothing but twisting force, right? The torque is nothing but force into distance, or if it is a vector, force vector and a distance vector, right? Force F or sine theta. So F is nothing but a force, R is nothing but position. So distance means position vector, right? The torque must be equal. So if you equate the torque, you will get at point, there are two forces now. So you'll exist two torques. So those two torques are equal at any point, right? So you equate this force. The first torque at O point. So what is the torque value? So what is the force value? Tension T. And what is the distance at T? What is the position vector for this? This is a position. For this force, this is a position vector. So what is the position vector? V, y. So torque into y. So at point P, so you have a force. What is that force? That means midpoint, OP. You have a force. What is that force? Omega into x, right? Into at what is the position vector for this? This is a force, na? So for this, the position vector will be like this, or this one. So that is x by 2. So what is that position vector? X by 2. You equate these two torques, you will get torque into y is equal to Wx into x by 2. So torque, that means tension into y is equal to Wx square by 2. For a consideration, you will assume that, so y is a small value, you are considering this y is very large, so that is equal to sag. I'm assuming that y is a tangential, that means horizontal, na? Horizontal vector, na? This y, if you increases this y, it will equal to sag, na? So that's why I am assuming that y is equal to sag. So what about x? X is my, if it is a sag means x will be expanded like this. So x is nothing but L by 2. So this point we can call it as a x. We are assuming, right? If this point is y means if you increases, this is equal to sag. This point is x means if you increases, so this point will be equal. So that means x is equal to L by 2. Now substitute. So from this, so what is y? Y is equal to Wx square by 2t. Alright. So y we can call it as a sag is equal to W. So what is the x value? L by 2. L by 2 whole square. by 2t. So what is that? W L square by 8t. So what is the sag equation? S is equal to W L square by 8t. So this is the formula for the sag for unequal weight of the equal weight of the towers. So what is a sag? Perfect sag. We should maintain perfect sag. Tightly connected system, that it has some advantages and disadvantages, right? Loosely connected system, that it has some advantages, some disadvantages. So you have to make both the things will together will ensure that the perfect sag point we should maintain. So what is that sag value? So this is the sag value. To maintain a conductor materials, cost will be reduces. Height, you don't have that much height, you don't want that much ground clear, you have that much ground clearance. All these things you will get at this particular sag value, right, for equal term. So from our observation, it is easier to find that the sag is directly proportional. So from this equation you will observe that. So from this you will understand, right? My sag is directly proportional to the weight of the conductor. Is it right now? If the weight of the conductor increases, my sag also increases now. The first factor is over. What is the second factor? Sag is directly proportional to length of the conductor. So if the length of the conductor increases, my sag is going to be increases. And after that, what about the tension? Sag is inversely proportional to tension now. Is it clear now from this equation? Sag is, all the factors are going to be satisfied. So this is a sag value to find equal weight of the towers. So what I did, I'll really explain one more time. So what I did means, so in order to calculate the sag value, you have two ways. So what are the ways? The system which is having equal towers and unequal towers. So if you have a equal towers, what is the perfect sag to maintain a transmission system efficient, right? If it is unequal towers, what is the sag value? You have to find out. So what is the first I'm going to take about the equal towers, equal height of the towers. So these two towers are going to be equal towers. So length of the transmission line is L, and the shape is nothing but catenary parabola. If you take the catenary, it will be very accurate, right? So the catenary, right? So what is the sag? The lowest point we can call it as a O. So what is this value? We can call it as a sag. Alright, but the curvature is very less. So now I am going to assume small curve. So the total curvature we don't want to estimate. That each and every point the tension is going to be similar. Right? I am assuming particular point. So what is that point P? If you assume a point P which is having x coordinate and y coordinate, right? So I am assuming this is x coordinate, the value is x. This is a y coordinate, the value is y. I am assuming, right? So after that, at point O, you have a force now. So what is that force? That is nothing but tension. At the portion of OP, also one force is going to be exerted. The turning will exhibit some force now. So what is that force? The force is nothing but weight of the conductor and the distance, right? So what is that force? Omega Wx. Alright. There are how many forces in the system? There are two forces in the system. If you assume one more point here, another force is there, but all the forces are equal. Alright. So what are the forces? Torque is one force and Wx is another force. Now be clear. So each and every point your torque is going to be a constant one, right? So what is the torque value? Torque is nothing but twisting moment. If you want to find out the torque, we require force into position vector. If you define in the form of a vector form, one is a torque value, another one is a position value, right? It requires a force value and the position value. So what is the force here? The first at point O, we have one type of torque now. So what is that force? Force is nothing but torque, tension, and what is the position? Y is the position. So the torque is nothing but T into Y, right? T into 1. Now another portion. OP. In midpoint you have one force na. So what is that force? Wx. What is the position vector here? The position vector is nothing but x by 2. So this is my position vector, or else this one also you can take it. So Wx into x by 2. These two torques are going to be equal. So Ty, that means tension into y is equal to Wx into x by 2. So from that y is equal to Wx square by 2t. Now I am assuming that this y is a horizontal one. So I am assuming that this y is going to be increases somewhat. So then it will be equal to sag. Na? So I am assuming that y is equal to sag. Y is equal to sag. So what about x value? So that means similarly this x is nothing but L by 2 now. I am extend this x. So this one is going to be L by 2. So put S is equal to sag. These are two assumptions. Right, assume. Yes, y is equal to sag, x is equal to L by 2. Substitute here. You will get y is equal to Wx square by 2t. So what is the sag value? W in place of x you have to put L by 2 whole square. WL square by 8t. So this is the final perfect sag we should maintain if the two transmission towers are equal towers. Got it na? So from this you will observe, you will conclude that what are the factors that are affecting the sag. From this you will assume, you will tell, right? So the sag is directly proportional to the weight of the conductor. Sag is directly proportional to the length of the conductor. Sag is inversely proportional to the tension of the system, tension in a transmission system. So this is about the sag calculations while erecting the transmission line, which is having a two towers. Two towers are going to be equal heights, right? If the two towers are equal height, this is the formula to ensure that the perfect sag will be maintained. If you put the perfect sag, means it is having a good design consideration. You will get a better result, right? Each for ice loading, for climatic conditions, right? So the tension must be within the limits, and all these things will get. So thank you for now. In the next session, we'll discuss about unequal towers, how the sag will be calculated. Right? Thank you very much.